Hello everyone. Today we are going to discuss the case number 3 of graphing exponential function transformations, that is stretch or compression. So first of all, we will see what is the general form of the exponential function in case of stretch or compression. Then what is the effect, and then we will discuss the examples besides plotting them on the. So first of all, the general form of the exponential function, when we have to see whether there is a stretch or compression, will be f of x is equals to a multiplied by b raised to power x. As we have seen in our previous lectures, the general form of different transformations. Similarly here, this general form is more like the general form of the exponential function. But here what important is the role of this value, that is a. A is basically, I have told in my previous lectures, is considered as the y-intercept or the scaling factor. On the basis of this a, we will decide whether the graph is just showing that whether the graph is stretching or compressing. So we are going to discuss the two main cases on the basis of this a. Just like on the basis of this b value, we decide whether the exponential graph is growing or decaying, and similarly on the basis of the x value, we check whether there is a horizontal shift, or on the basis of y value we check there is a vertical shift. But here on the basis of a, on the value of a, we will decide whether there is a stretch or compression. So let's see on what value of a there will be a stretch, and on what value of a there will be a compression. So if I write here, if a is greater than 1, one condition is this, and the other is if a is between 0 and 1, that is less than 1 and greater than 0. These are the two main conditions. So let's see what is the effect if a is greater than 1. If a is greater than 1, the graph will stretch vertically. Now what is meant by stretch vertically, we will discuss it with the help of example. But currently you must know, whenever you came across any function with such general form, you should have the information that if a is greater than 1, it stretches vertically. But if a is between 0 and 1, then it compresses vertically. So we will see on the graph that how it stretches or how it compresses vertically. So it means when the value of a is greater than 1, just like 2, 3, 4, 5, 6, the graph will stretch vertically. But if it is less than 1 and greater than 0, like 1 by 2, 1 by 3, 1 by 4, in that case it will compress vertically. Keep this in your mind that the impact will be vertically. The effect will be vertical. So for example, if a is greater than 1, the example will be like y is equals to 2 dot 2 raised to power x. So here this 2 is representing a. As a is greater than 1, it means the graph of this example will stretch vertically. But in case of y is equals to 1 by 2 dot 2 raised to power x, here this 1 by 2 is representing a. It means a is less than 1. So it means the graph of this example will compress vertically. Now let's take the example so that you can have clear idea that how they differ graphically from the parent function when the value of a is greater than 1 or when it is less than 1. So here I have made 3 tables already. So one table is representing a parent function. So I'll write here, this table will represent a parent function table. It means we will take random values of x and y that we will be needed in while graphing it on the coordinate axis. Here we will have parent function. So this parent function will be, it means f of x is equals to 2 raised to power x. Now this is the parent function. There is no scaling factor other than 1 here. So the effects will not be on this function. Now the other one is in layman term I can say are the child function, or the functions in which one function will be the one with the value of a greater than 1 and the other will be with the value of a less than 1. So if I represent this function, it will be y is equals to 2 dot 2 raised to power x, and the other function is y is equals to 1 by 2 dot 2 raised to power x. So keep this in your mind that this 2 here is a and this 1 by 2 here is also a. So let's plot them so that we can check their difference. So first of all, for the parent function, so we will take random values of x as -2, -1, 0, 1, 2, 3, 4, and the corresponding value of y on the basis of this function, that is 2 raised to power x, will be 0.25, then it will be 0.5, then it's 1, then 2, it will be 4, 8 and 16 and so on. These are the random values I have taken. Now we will take the same random values for the other two functions as well, and we will find their corresponding y value. So here again we will take -2, -1, 0, 1, 2, 3, 4, and for the other function as well, -2, -1, 0, 1, 2, 3, 4, and their corresponding values are, that is the value of y will be 0.5, as we know that by putting the value of -2 in this function we will get 0.5 after solving it. Then for -1 it will be 1, for 0 it will be 2, for 1 it will be 4, for 2 it will be 8, for 3 it will be 16, and for 4 it will be 32. And so similarly for the other function, that is y is equals to 1 by 2 dot 2 raised to power x, we will have the corresponding values as 0.125, it will be 0.25, then it will be 0.5, then 1, 2 and 4 and 8. So these are just the random values. One is the parent function, and the other remaining two that are representing the stretch and compression. So here if I write or represent, here we will have a stretch because the value of a here is greater than 1, and on the other side we will have a compression or a compress. So I will plot these values on the graph, and the red color will show the stretch, the blue color will show the compress, and the black color will show the parent function. So the parent function have -2, on -2 it is having 0.25, then on -1 it's having 0.5, then on 0, 1, then 1, 2, so then 2, 4, I'm plotting the points, then on 3, 8. So if I join them together, I'll get the graph like this. So this is the graph of the parent function, that is f of x is equals to 2 raised to power x. Now I'm going to plot the graph of the stretch, and I'll take the points of the stretch and I'll use the red color so that you can have a clear concept about it. So for the stretch we have on -2 we have the value of y 0.5. So on -2 will be 0.5, then on -1 it is 1, then on 2 it's 0, then 1 or 4, and then 2 and 8 it's 2, and here it is 8. So if I join them together, it will be like so. This is the graph of the stretch, that is y or f of x is equals to, it's the same, y or f of x. So I'm writing y is equals to 2 raised to power x. Now I will plot the compress, then we'll discuss their graph. For compress we have 0.125 on -2, okay, 0.125, it will be somewhere here, then 0.25 on -1, okay, it will be somewhere here, then 0 on 0.5, okay, then 1 on 1, then on 2 on 2, then 3 on 4, and then on 4 it will be 8. So if I plot them, it will somewhat look like this. So this is for y is equals to 1 by 2 dot 2 raised to power x. So this is the graph of the three different functions. Black represent the parent function, red represent the function where there is a stretch. This function is stretching along the y-axis, and this is the compress along the y-axis. So I already told you about it, that it stretches vertically when a is greater than 1. Now it is stretching in the vertical direction. You can understand this concept easily by considering if you have a rubber band and you stretch it with your two fingers vertically, it will go in the vertical direction. It means that it is stretching vertically. Same is the case here, that the function y is equal to 2 dot 2 raised to power is stretching vertically. It means that that it has high values of y corresponding to the same values of x. X value remains same. It is if you see here that the x values are same, but the y values are changing. So that's why there is a vertical stretch or compress, and when there is a stretch, the y values corresponding to the x values will be greater, while they in the compress, the y values in comparison to the x values will be smaller. For example, in the stretch on 3 we have 16, but on the compress on 3 we have 4. It means we have higher value of y on 3 in stretch and lower value of y on 3 in the compress. So this is how you can plot the stretch or compression. That's all from today's lecture. Thank you.